Hello, 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 everybody, and welcome back. Welcome back. We're on question number 9 of our 9th grade Pascal contest from 2009. In the diagram, we've got sort of club symbols, any card players watching, so any clubs may be moved to an unoccupied space. What is the smallest number of clubs that must be moved so that each row in each column contains 3 clubs? Okay. So, we're asked for the smallest number, and I don't quite have sort of a procedure in mind right now, so I'm looking at 1, 2, 3, 4, and 5, and let's look at some possibilities. So, first things first, let's actually just copy this picture over. Now, I'm not going to draw club symbols, because they take longer to I think, for me to draw than is really necessary. So I'm just going to use stars. I think it was a 5x5. Was it a 5? Yeah, it's a 5x5. Okay, so I noticed right off the bat that in these first 2 columns we have 4 stars. Now, if every column and row are supposed to have 3, or at least 3, we're doing fine. Okay? We have to be on the lookout for 2, and then another one, and then 1, and then 2. And then 1 over here. Okay, so let's take a look here. I've got 4 in the first row, 4 in the next row, 2 in the next row. So something's going to have to be added to this row. Now, we don't add new clubs, 3 here and 2 here. We don't add new clubs. We're just moving the clubs around. Okay? So I could take this club here, and I could move it down here if I wanted to. Any club can move anywhere. It's not like a checkerboard where they have to hop each other or anything like that. Or in our case, any stars. So let's just take a look. We've got 4, 4, 2, 3, and 2. So that's going to be 15 stars or clubs. And 15, well, if I divide that by 5 rows, that's going to be 3 each. So we have to have 3 stars in each row. You can't have a row that has 4, because that means one of these rows would have to have 2. Okay. And similarly for the columns. So when I'm noticing here that we've got 4 in each of these, I know that they're going to have to move. 2 of them are going to have to move down to this bottom, this end column that has just 1 star. Similarly, if we take a look, these 2 rows here have 4 stars amongst them. They're going to have to be redistributed to the rows that have 2. So, I guarantee you have to move at least 2 of them, because you have to get a star out of this row and a star out of this row. Or it's not, I said row. Star out of this column and this column. So we have to move at least 2. Do we have to move 3, for example? I don't know. What I'm going to do is I'm going to say, well, hey, this row here has 4 stars in it. This column here has 4 stars in it. So let's remove this common star, the star that's common to both of them. Okay. I'll use purple for the rows that have too much, and I'll use green for the rows and columns that have not enough. Okay. So, in terms of intersection, we'd like something, a star here, and we'd like a star here. Okay? Because that would get them into this end column and also add things to these deficient rows. This one and this one. So what I'm going to do is I'm going to take this star here, and I'm going to add it here. Okay? And now what have we got? If we reevaluate the situation, this row is fine. This row, the second row, still isn't. This column is fine. This column is fine. This row is fine. And now this row is fine. But we still have a column that is not finished and a row that isn't finished. So now we take a look at our columns that are not that are sort of surplus columns, let's call them. They've got too much in them. Surplus rows and surplus columns, and I find that they have a star in common as well. So let's take that star and move it to another empty spot, And now let's take a look. This row now only has 3. This column now only has 3. This column has the 3 that we need. This column always had 3. And this row here also has the 3 that we need. So we're satisfied. We moved 2. Could we do it in less? Well, again, no, you can't. You have to move at least 2 stars, one out of the first column and one out of the second column. Otherwise, they're going to be stuck with 4. And how do we know we have to remove and get those columns down to 3? Because we only have just enough stars, or if you're talking about the actual question, we have just enough clubs to get 3 in each row and each column. We have 15, that's exactly the bare minimum we need. So we're going to have to use every star. Can't have any extras sitting around. So having those 2 columns, well, I need to pluck something from one column and another from another column. That's guaranteed 2 moves, but we found a way to do it in 2 moves. So 2 is going to be our answer. I think that's B. I think they were going up in order. Yes, it is. So that was a nice little question. I like that one. Kind of nifty. So if you liked it too, by all means leave a comment. Maybe you approached it a different way, but I'm very satisfied with that. Onwards to question number 10, where we finish off part A.